Hello chemistry students, today we are looking at doing some Lewis structures for molecules or atoms, and I just wanted to do a few more examples than what was in the video that you watched on Edpuzzle. So I got these examples over here. I don't know if I'm going to do all of them, but I'm going to start with HF. So the very first thing that you got to do is count up the total number of valence electrons, and I figured that out to be 8 valence electrons already because hydrogen has 1 valence electron, and according to the formula there's 1 of them. So 1 valence electron times 1 atom is 1. Fluorine has 7 valence electron. According to the formula, there's 1 of them. So that's 7. 1 plus 7 is 8. So what I'm going to do is I am going to draw the very simplest structure that I can. And the very simplest structure I can is to put the two of them in a straight line with a bond between them. Once you have that created, what you're going to do next is try to count up how many valence electrons you've used. Remember, the line is 2 electrons. So if I started with 8 and I used 2, I have 6 remaining. And I'm going to place the electrons in around the ligands, which we don't really have ligands here because there's no central atom. But I'm going to place them where I can. So I have 6 electrons to place. Hydrogen is already happy. It has 2 electrons. The line represents 2. So I can't put more around hydrogen because now it would have 3. And hydrogen is the only atom on the periodic table that is satisfied with the duet rule. So what I'm going to do is I'm going to take these electrons and I'm going to place them around the fluorine. And when I do that, I always spread them out first to try to show symmetry, because symmetry is kind of the key to getting through some of the really rough ones. Nature loves symmetry. So there we go. I've put in all of my electrons. And the last thing that I'm going to do is I am going to check to make sure that I've satisfied the duet or octet rule. Duet meaning that hydrogen should have 2 electrons by it, and it does. They're right there. And the fluorine should have 8. 2, 4, 6, 8. So in this case, that's it. This molecule would be done. Everything is satisfied. This is what I would draw on the test or quiz. All right, example number 2 is carbon tetrafluoride. So if I'm trying to do carbon tetrafluoride, when I look at the formula, this is what it means. There's 1 carbon, there's 4 fluorines. So the first step is to determine how many valence electrons there are, and I determined that there were 32. How did I get 32? Carbon has 4 valence electrons, and there's only 1 of them, so that's 4 electrons. Fluorine still has 7, just like the last example, and there are 4 of those, so 7 times 4 is 28. Add those together, I get 32. So what I'm going to do now is I'm going to try to draw the simplest structure I can. Remember, nature loves symmetry. So I'm going to start with carbon as the central atom, and I'm just going to kind of place the fluorines. Now I could do this, and that's very symmetrical. But if I want to try to preserve symmetry as much as I can, I'm going to do left, right, top, bottom type symmetry. So I'm going to just spread those out a little bit. So kind of like the same way that you do a Lewis structure. I'm going to go on the bottom. Imagine that there's a box around this. And I'm going to put my atoms on the top, bottom, left, and right. And now this is very symmetrical in all directions. If I put in some bonds here, I'm not going to make you watch me put all the bonds in. So there you go. I put the bonds in. The next thing I got to do is there's 1, 2, 3, 4 bonds. Remember, each bond is 2 electrons. So this is 2, 4, 6, 8 electrons. So I think I have 24 electrons remaining. How did I figure that out? I took 32 minus 8, 2, 4, 6, 8, and that's where I get my 24 from. So I'm going to place the remaining electrons in around these outer atoms, the ligands, as lone pairs. And I'm also going to do that as symmetry. So for example, as I add 1 here, and I'm doing them as pairs, so if I put 2 in there, I'm going to put 2 in over here. And I'm going to pause the video while I put these in, so they'll kind of magically appear, but I'm still going to do them in steps, and you'll be able to see the symmetry. So I put some lone pairs in, 2, 4, 6, 8. I have more to go, so I'm going to add some more. So I added more, and I'm still being very symmetrical when I do it. Right now I have 2, 4, 6, 8, 10, 12, 14, 16. I'm trying to get up to that magic number 24. So I've used up 16 more now. I have 8 left to go. And I think I've used up all of my remaining pairs of electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That's 24 electrons. This should be a completed molecule at this point, but I do need to check and make sure that everything's satisfied. So anything that is hydrogen should have 2 electrons around it. There's no hydrogen, so I'm okay. Any other atom should have 8 electrons around it. And when I'm looking at this, there's 5 different atoms that I'm going to have to check, so I'm going to do that right now. This fluorine atom that I've highlighted has 2, 4, 6, 8, because remember the line counts as 2. This fluorine atom has 2, 4, 6, 8. So I'm okay with that one. I'm going to move over to this one. 2, 4, 6, 8. And if I go down here to the bottom, 2, 4, 6, 8. Don't forget about the carbon in the middle. 2, 4, 6, 8. So it looks like everybody's happy. This is the final molecule that I would draw in a test or quiz. And I'm going to do NH3 next, just to see how that one works out. All right, so here we go with NH3. NH3 simply means that there's 1 nitrogen, 3 hydrogen, and first thing I gotta do is I gotta figure out how many valence electrons there are total in the entire structure. I think there are 8. I get 8 by taking nitrogen, which has 5 valence electrons, times 1. And each hydrogen has 1 valence electron, but there's 3 of them. So 5 plus 3 is 8. I need to draw the simplest structure I can that has the N's and the H around it. We try to preserve symmetry as much as we can, but with this particular one, there's no way to do that. So I know nitrogen is going to be in the middle because then I can get the left and right symmetry. So that means that this H just has to go on the bottom of the top. It does not matter where you put it. Keep in mind we envision the N in a box, and you can only put things to the left, to the right, to the bottom, or top. That's it. So once I have that simple structure, I'm going to put some bonds in, and this is what I get for some bonds. There we go. I have 2 valence electrons remaining. How did I get 2? Because I started with 8. 2, 4, 6 bonds were created. Well, 3 bonds. Each bond has 2 electrons in it, so 6 electrons were used. 8 minus 6 is 2. If I have 2 electrons remaining, I have to put those in. Now it says I should put those in on the ligands. I don't have to do that because hydrogen only wants 2 electrons, and this hydrogen has 2 electrons by it, and this hydrogen has 2, and this hydrogen has 2. So when I put my remaining 2 electrons in, I would actually put them on the N. And now, when I check for the octet or duet, I can get my magic pen back out. I can draw a little circle here. There we go. If I take my circle, that hydrogen's happy. It has 2 electrons by it. This hydrogen is happy. It has 2 electrons by it. This hydrogen is happy. It has 2. And if I look in the middle, the nitrogen, 2, 4, 6, 8. All hydrogens have 2. Any other atom has 8. Very happy molecule. All right, just moving down the list, I'm going to try to do these nitrogen examples. And the nitrogen example here, I have 2 nitrogens. So if I'm going to determine the number of electrons, that's 10. Each nitrogen has 5 valence electrons, but there's 2 nitrogens. So that gives me a total of 10. Sorry about that. There you go. I'm going to draw the simplest structure I can. The simplest structure I can with 2 nitrogens, just put them in a straight line. I have used 1 bond, 2 electrons. So the number of electrons I have remaining are 8. 10 minus 2 is 8. My 2 electrons are right there in that bond. Put the remaining electrons in. I'm going to preserve symmetry when I do that. So here we go, trying to be really symmetrical as I put these in. I got to get 8 in. 2, 4, 6. I would probably put the other 2 over here to try to be symmetrical. And when I've done that, I'm going to finally check to see if my octet and duet is okay. So get my spotlight out. Need to be a little bigger. There we go. This nitrogen, 2, 4, 6. That nitrogen is not happy. So if I go look at the other one, 2, 4, 6. That nitrogen is also not very happy. So what I need to do in this case is erase a pair of electrons. So I'm just going to go in here and erase a whole pair, not just one, both of them at the same time. And when I erase a pair, I'm going to put another bond in between them. So yeah, when I start to count up electrons now, I got 2, 4, 6. I still have 6 around this one, but look what happened to the other one now. 2, 4, 6, 8. There are now 8 around this one. So what I need to do now is erase another pair of electrons. And if I erase another pair of electrons and put a bond in between, everything should be perfect, right? Well, no, because this nitrogen still only has 2, 4, 6 around it. And this nitrogen over here now has 2, 4, 6, 8, 10. That was the wrong pair to erase. So I'm going to put them back. There they are. Just put them back there. I'm going to erase a pair over here. And if you notice what this is going to do, I kind of use this phrase a lot, symmetry is the key. If I erased the pair up here last time, go for the pair down here. Put that bond in between. This nitrogen now has 8 electrons around it. Two, 4, 6, 8. This nitrogen over here has 8 electrons around it. 2, 4, 6, 8. Total number of pairs should be 10. 2, 4, 6, 8, 10. You can't invent extra electrons. We just have to share them more efficiently. So in this one, this was actually one of the ones that was in the Edpuzzle that you watched. There's a triple bond between the 2 nitrogens. And when there's a triple bond between the 2 nitrogens, we're showing that by having 3 lines there. All right, here we go. So this one's going to be for NO, but notice there's a little bit of something weird going on here. It's got a positive charge. I'm just going to start the exact same way that I'd start any other problem. I'm going to let you know right up front, I made a mistake, and I'm going to fix that because we got to talk about what that little plus means. So I think the total number of electrons is 11. And I get 11 because nitrogen is 5 and there's 1 nitrogen. Oxygen has 6 valence electrons and there's 1 oxygen, so there's 6. But this molecule ends up being positive. And if you remember how you get to have a positive charge is you lose an electron. So somewhere when I'm making this molecule, some electron gets randomly lost in the process. So I'm actually not starting with 11 because it's a +1 charge. I'm actually going to be starting with 10. Not 11. And it's because of that plus charge that's on it. So this problem actually works out to be super similar to the one that I just did, where if I draw the simplest, most tentative structure that I can between them, I'm actually going to have 1 bond, and when I count the remaining electrons, I'm going to have 8. I'm just going to skip and go right to that point. So there you go, I just kind of skipped to the end product because it's exactly like N2, it's just that there's an O instead of an N here. There was 10 valence electrons, 2 things, there's got to be a triple bond. Check for the octet, 2, 4, 6, 8, there's 8 around my oxygen. Check for the octet on nitrogen, 2, 4, 6, 8. Here's something that's different though, because this had a charge, because it's a polyatomic ion, we put these big brackets around it. And the big brackets say that this molecule ended up having a positive charge. So that's something that's a little bit unusual or a little bit different. You just might want to take note of that so that you understand it. All right, this is my last example that I'm going to do with you. The example, I think I'm starting with 23 valence electrons. That's the first step in any one of these is to count up the valence electrons. So nitrogen has 5. Just for the record, 23 is wrong. I'm going to show you that in a minute. Oxygen. There are 6 valence electrons in each oxygen, 3 oxygens total, so it's 18. 5 plus 18 is 23, but here's the key, there's a negative sign. And in order for a molecule to become negative, that means somewhere along the process it's gained an extra electron. So if you gain an electron, you become more negative. So there's actually 24 electrons when I start. And I got to take that little negative sign into account as I go through. So once I do that, now that I know the total number of electrons, I'm going to draw the simplest structure I can. The simplest structure that I can probably looks something like this. And I'm going to now put my bonds in. Now that I put those bonds in, I can count up how many electrons I have remaining. I think I have 18 electrons remaining because I used 2, 4, 6 electrons. So 24 minus 6 gives me 18. So I'm going to put those 18 electrons in on the ligands. I'm going to do that with symmetry. At this point, I have used 6 of them, so I have 12 more to go. But you can see I'm being very symmetrical in my approach. And I have now put in another 6 electrons, so I have 12 electrons total that I've added. I have 6 left to go. And I have no electrons remaining because my lone pairs should be 18, 2, 4, 6, 8, 10, 12, 14, 16, 18. Or I can count up all the electrons. If I count up all the electrons, I'd get to 24, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So there's no more electrons. I can't invent any more electrons. I do need to do the final step, which is to check for the octet or duet rule. And in this case, if I'm looking for that octet/duet rule, there are 8 electrons around oxygen. Perfect. There are 8 electrons around oxygen. Perfect. There are 8 electrons around oxygen. Perfect. 6. Not perfect. So the strategy at this point would be just to pick a pair. You can pick any pair you want to and erase those. I'm going to erase those right there and add a bond. Now if I erase the pair here, I'm not going to put the bond over on the other side. I'm going to put, if I erase the pair on this oxygen, I'm going to put the bond between these two. And now if you look very carefully, everybody's happy, everything's satisfied. Every oxygen has 8 around it. The one nitrogen that I have has 8. 2, 4, 6, 8. So hopefully these extra problems help you with the process of doing some Lewis structures.